All right, so let's say you're experiencing rack buffer jams, anything like that. Basically, what's happening is that transition point from being sampled right here in front of these sensors to the back alleyway right here where it hits against this S17 sensor, the rack is just not hitting its points on time. So the rack could be stalling halfway here with the belt spinning underneath it. It could be getting part of the way or just jammed up actually on the feeder right here. So there's a couple things we'll look at real quick. So the easiest is seeing the transition itself. So if you put a rack right here, the rack should not be front heavy or back heavy. I mean, if you push on the back, you might be able to pick it up just a hair. You can see that right there. You want a little bit of a drop off because the way it works, it's all gravity. So the belt is basically dropping down onto this platform right there in the corner. If it's too high, then this will pick it up and basically cause it to jam against the front of this, like it'll actually hit the front of that white piece. If it's too low, it actually will let the belt spin underneath it. So you can see right there's a little bit of a gap there. I'm not too much of a fan on that. We could do a little bit more adjusting, but what happens here is that the belt could basically spin underneath it, especially if the rack is front heavy, and the rack will just basically stay put. It won't move all the way to the end, and that's where you get that error where it'll basically stop short right here because the front end is heavy. You know, and then that back end will just lift off and then the belt will spin. So what you're looking for here is there's a couple alignments. So we have the screws down here on both sides. Now normally what I do is I like to etch it. Alright, sorry. So I'll go ahead and etch it right here. So the bottom of this plate, you just want to make a line across the bottom of this whole plate here, just so if you want to come back to the point you were at and just kind of go across here. So if you do move it up and down, you can kind of go back to your reference point. So for our purposes, it's going to be this screw right here, and when you undo that, like I said, you want to just barely tap up, maybe just, you know, tap down, and you'll see that rack kind of lean forward, lean backward, you know. But like I said, we're looking for a little bbit of a transition where it goes down, but not enough to where the belt will spin underneath it. So you kind of have to find a fine line. It's basically like, oh man, half a millimeter, maybe half a centimeter or something like that. It's much less than that, but something to that transition. So that's pretty much how we do it. Same thing with this corner. If it's coming off of this belt here and transitioning to this belt, and it's too high on this end, then this will have to be lowered so the belt is higher up, so it climbs up and this belt grips it as it takes it up. So hopefully that helps out. And like I said, the best way to test this is putting a whole bunch of racks on with just front heavy. So you want to put, like, you know, 3 tubes, 4 tubes just in the front with DI water. That way it's front heavy. That way it causes the most likelihood to fail. So if it gets this back corner, we'll know pretty quickly if it is lifting off that belt there, because the weight is all in the front. And if it can't handle front weight, then the alignment needs to be tweaked just a little bit more. So there you go.